Today we're talking about the theorem that states a point is on a perpendicular bisector of a line if and only if it is equal distance from each of the endpoints on the line segment. So what we need to do is start off by considering 2 points, points A and B. It doesn't matter the distance that they are. All right, what matters is that we have them, and then we're going to construct a line segment that joins these 2 points. We're going to call this line segment AB. Next, I'm going to plot a point that is going to be equal distance from each of these endpoints. When we say equal distance, if we have a line segment and we want it to be equal distance, that means we're going to plot the midpoint. Our midpoint for us today is going to be C. Since C is equal distance from A and B, AC is congruent to CB. That's those two little lines. Now, we have another point, D, and we're going to put it anywhere on the plane. Now, for D to be equal distance from both A and B, AD and BD should be equal distance. But we have no way of proving that. We assume that D lies on the perpendicular bisector of AB. Now, when we talk about the perpendicular line segment, please remember that it is only a perpendicular bisector if it cuts the line segment into 2 equal parts at a 90 degrees. We now need to look at AD and BC to see whether or not D is equal distance from both. We have these 2 triangles. We have triangle ACD and BCD. Now, in these 2 triangles, we've already said that AC is congruent to BC. We can also see that CD is the common in both these triangles, meaning that ACD and angles BCD are on the perpendicular bisector, so both of these angles would have to be 90 degrees. Thus, by the side angle side postulate, these 2 triangles have to be congruent. So for it to be congruent, that means that segment AD and segment BD both have to be congruent to each other so that they could be equal distance between the 2. Thus, the point has to lie on the perpendicular bisector to make it so that these 2 points are equal distance. We must have that 90-degree angle in between. We must have the base of our triangle and a common side, giving us that sides AD and BD are congruent.